Today we're going to be talking about solving quadratic equations using the square root property. And what does that look like? Well, in particular, if I know that, for example, a number squared is equal to 9, then there's two options on what that number could be. That number could either be positive 3 or it could be negative 3. And the way that we would formally solve that is we would undo the square with the square root, but when we undo that square with the square root, we need to make sure to use a plus minus on that answer. And that gets at the idea of before when we were simplifying variables to say that the square root of x squared equaled x, that was only if x was greater than 0. Remember, we always sort of specified, make sure those variables are positive to do that simplification. Otherwise, the square root of x squared is technically the absolute value of x. So if we're talking about a solution to a problem where a number squared gives you another number, then there's always two answers. It's either the positive version of that root, or it could be the negative version of that root. And that's really what the square root property boils down to. So if you're going to solve something by the square root property, if you are even given a more complex expression that is being squared, let's say, then the first thing you always want to do is isolate that complex expression. So you want to somehow get it where we've simply got the term all squared equals a number. Then you're going to isolate, then you're going to undo that squaring by square rooting both sides. And when you square root both sides, you'll want to make sure to use a plus or minus on that answer. And that will end up being your two solutions. Now the caution here is that that answer better be greater than or equal to 0 if this is going to work. If that answer was less than 0, there would simply be no solution. So if I got x squared equals negative 9, and I tried to square root both sides, well, the square root of negative 9 does not exist, so there would be no solutions to this problem. So that's always something that you should double check as well. So let's take a look at an example of this. If I had, for example, x squared is equal to positive 49, the way that I would isolate x is by square rooting both sides, making sure to use a plus or minus. So x is either the positive square root of 49 or the negative square root of 49. Positive square root of 49 is 7, negative square root of 49 is negative 7, and we're done. Versus is if you had x squared is equal to negative 49 and you tried to do the same move, this does not exist, so there would be no solution. So that's always something worth keeping in mind. Now let's say you have a small coefficient. Well, you still have to get the x squared by itself first. So you're going to want to undo multiplying x squared by 4 by dividing by 4 first. Then you can undo the square with a square root, making sure to use plus or minus. And in this case, you would be like, oh, does square root of 5 exist? It does. It's just not a very pretty number. So you would just note that x is either positive root 5 or negative root 5 and call it a day. The square root of 5, it exists. It's still a positive number under that root. He's just not a very pretty one. Now, if you have more than one thing under there, then whenever you undo that square with the square root, it's still going to be plus or minus, but then you get that whole expression that's under the root. In this case, x minus 3 is equal to positive root 36 or negative root 36, which is really just 6. So you're actually going to want to split him up into two equations. Either the x minus 3 is equal to positive 6, or the x minus 3 is equal to negative 6. And then in both equations, you'll have one step in order to get x by itself. But notice how the final answer didn't just become plus or minus the same number. You actually end up with two very distinct solutions. So let's keep on going. So let's say we kept on going and we want to get, again, this thing squared by itself. Well, how am I going to do that? Well, first I have to undo addition subtraction. So then we get x squared plus 1 squared multiplied by 2 is equal to 50. Then we want to undo multiplication division. So we want to undo multiplying by 2 by dividing by 2. So then we get x plus 1 all squared is equal to 25. Then we're finally ready to undo the square with the square root, making sure to plus or minus. So we end up with 2x plus 1, what's underneath, that what's still left after we undo the square with the square root, is equal to either positive 5 or negative 5 because it's plus or minus the square root of 25. So that's where we have to split them up into his two equations. So either 2x plus 1 equals positive 5 or 2x plus 1 equals negative 5. Both of these will be two-step equations, so I'll get 2x plus 1 is equal to 4 when I subtract 1 from both sides, or 2x is equal to negative 6 when I subtract 1 from both sides. Sorry, if I said 2x plus 1, that plus 1 part has been canceled out. Then undo multiplying by 2 by dividing by 2 on both sides, so I get x is positive 2 or x is negative 3 as my final answers. Again, notice how they're actually distinct. So for these next ones, I actually want to kind of show you again sort of a reminder of two different ways this could go down. So if I either had 4x squared equals positive 11 or 4x squared equals negative 11, in both cases I would need to get the x squared by itself by dividing by 4. So then I would get x squared is equal to 11 over 4, or x squared is equal to negative 11 over 4. If I then went ahead and undid the square with a square root on both sides, being sure to plus minus, in this case there would be no solution since there is a negative under the root. So this problem's answer would be does not exist. There is no real solution to that problem. Versus the second problem totally does exist, even if it's not very pretty, because then I would get x is equal to either positive root 11 over 4 or negative root 11 over 4. Notice how that negative is outside of the square root. To simplify that further, I can distribute the square to both of those, or the square root to both of those. So I get square root 11 over the square root of 4 is 2, or negative square root 11 over 2. And those would be my final two beautiful solutions, and I'm going to rewrite that 2 a little bit neater. For this next one, I want to do the same sort of deal if I want to get the thing squared by itself first. So I'm going to undo subtracting 720 by adding 720 to both sides. Then I want to undo multiplying by 80 by dividing by 80 on both sides. So then I get a squared is equal to 9. Then I want to double check that answer is positive. He is indeed positive, so I'm going to undo the square with the square root, making sure to plus or minus that final solution. So a could either be positive 3 or negative 3 as my final two solutions. I'm going to go ahead and encourage you to pause your video and try these next two problems yourself, and then we'll go through them. So for the first one, the thing squared is already isolated, so we just want to plus or minus the square root on both sides. So I get g plus 5 could either be positive 6 or negative 6 for plus or minus the square root of 36. So I'm going to set that up as my two separate equations. Then for both equations, I need to subtract 5 to undo adding 5. So I either get g as 1 or g is negative 11 as my final two solutions. For this next one, I need to undergo the same sort of process, so I first want to undo subtracting 16 by adding 16 on both sides. So then I get 2 parentheses u plus 7 squared is equal to, and then if I'm adding that up, 4 plus 6 is 10, carry the 1. That gives 5, so that would be 350. Then divide both sides by 2. I get u plus 7 squared is equal to 350 divided by 2 gives you, what, 175, I believe, but I'm actually a little bit paranoid, so I'm going to double check my math here to the side. 2 goes into 3 one time, 1 times 2 is 2, 3 minus 2 is 1, drop down to 5, 2 goes into 15, 7 times 2 is 14, 5 minus 4 is 1, drop down to 0, 2 goes into 10 5 times, yes, 175. Then we're going to undo the squaring by square rooting and plus minus, so I get u plus 7 is equal to positive or negative root 175. I'm going to break down 175 a little bit further in order to figure out how that root's going to simplify. In particular, it looks like 25 times 7 is going to give us 175. The way I did that in my head was 25 times 4 is 100, 25 times 3 is 75, 4 plus 3 is 7. 5 breaks down to 5 times 5. So in particular, we're going to rewrite this as plus or minus the square root of 5 squared times the square root of 7. And the square root of 5 squared just leaves us with 5, so that would be plus or minus 5 root 7. And then as our final step, in order to get u by itself, we're going to have to subtract 7 from both sides. And that -7 is just going to be chilling on the outside. You can't combine him with the 5 because the 5 is being multiplied by the square root of 7, and you can't move him underneath the root because that 7 is currently not in a root. So that would just be your final answer. U would be equal to -7 plus or minus 5 times the square root of 7. So in order to solve these problems, your goal is to get the thing squared by itself, and then to undo squaring it by square rooting both sides, and then noting that it will be plus or minus the square root of answer for your solution. Now you do need to make sure that on that right hand side where you're writing plus or minus the square root of whatever, that whatever is bigger than or equal to 0. If that whatever is negative, then that's no good. That means there would be no real solution. So again, if you find yourself square rooting a negative number, that's a no solution situation. Otherwise, you're going to end up with 2 separate solutions. Ideally, hopefully that plus minus square root actually simplifies to a nice clean integer so that whenever you are solving, you get a very clean number. Otherwise, just simplify that square root as much as possible, and then make sure to include that plus minus on that solution.